Welcome to this environmental research seminar sponsored by M-LEEaD Center. So I am Sung-Kyun Park, Associate Professor in Epidemiology and EHS, also co-director of the Integrative Health Science Core of the M-LEEaD Center. So I'm very pleased to introduce today's speaker, Dr. Vy Nguyen. Dr. Nguyen is a postdoctoral fellow in the Department of Environmental Health Science at the University of Michigan, and also in the Department of Biomedical Informatics at Harvard Medical School. So Dr. Nguyen earned a BS in Applied Mathematics from Baylor University, and her MS and PhD in bioinformatics from here, University of Michigan. So her research interests involve leveraging her computational skills to characterize chemical exposures disparities, health disparities, exposome, and algorithmic bias. So she will be talking about very interesting study of environment-wide association and occupation. So please join Dr. Nguyen.
Okay, so I'll jump right in. Let me just do that so I can see my notes. So this is work done with all three of my bosses. So Justin Schrag here at Harvard, Olivier Joliet, and then Maureen Salter is also on here as she was on my committee dissertation committee and had an important comment that will help this project. So jump right into the background. So according to the UN, a worker dies from toxic occupational exposure every 30 seconds. So this really lends urgency to really understand like what are differences in occupational, like which occupations are at high risk. However, most study that looks at these differences in chemical exposures by occupations, they tend to only focus on one chemical or one chemical family at a time and in a very selected groups of workers. And so what these studies may miss is that they may miss this complete pictures of being exposed to a slew of toxicants if they only direct their attention on one chemical or one chemical family at a time. And so really there's a need for a comprehensive and untargeted approach to study really chemical differences by occupation across as many chemicals as possible as across a variety of different occupations. As another research gap, few studies some studies that do look at multiple chemicals across a variety of different job description in industry, what they'll do is they'll focus on a different type of measurement, as in like estimates of exposure and some estimates of exposure based off of a job title. So if you're familiar with like a job exposure matrix, and so this is a little bit of circular because it's like you're estimating someone's exposure based off their job. And some do use air measurements at the workplace, but then the question becomes like, okay, so we know that this is the air measure at the workplace, like how much actually goes into the body. And so this is why there's an advantage of using biomarker data, as it provides an internal dose within the human body that could be that could be related to a toxicological response. In particular, biomarker equivalents have been developed to define like what is that concentration, what is that cutoff of that chemical and its metabolite in the human body, depending on the biological means such as blood, urine, or serum, that is based on an acceptable exposure value. And so there's been a study that has compared like what is someone's actual like chemical in their body, in their blood, and how does that compare to this threshold that's defined based off of some sort of acceptable guidelines, and that's exposure values such as reference dose, so like a targetable daily intake or minimum risk levels. Because if your biomarker is above that threshold, that could imply that you may be at a risk for adverse health effects of that. And so this comparison between what is the biomarker levels in the body compared to the threshold, this has been compared in the general US population. But the insight we want to apply here is like what does that comparison different by different occupation? as we hope that such comparison would help identify which toxicants and which chemical really should, or which occupations should be prioritized for further, say like human biomonitoring, health risk evaluation, and targeted intervention. And so kind of moving straight into the objectives here. So we leveraged the National Health and Nutrition Examination Survey to conduct this analysis. So this right here, this is part of the CDC's mission to assess the health and nutritional status of the US civilian population. We have, for this analysis, we will use, look at 129 chemical biomarkers and 51,000 participants. And these participants, their occupation range from white to blue collar workers from 20 different industrial sectors and 7 unemployed groups. And so we will leverage this data set right here to identify occupations who are subject to high exposure, as well as any risks associated with multiple toxicants. And so our specific objectives here is we'll look at differences in chemical biomarker levels across the different occupation. And then from there, we're going to be able to, we're going to use hierarchical clustering to identify like which occupations have similar chemical exposure profiles. And then finally, we bring in the biomarker equivalents to identify like which occupations have chemical biomarker levels that it may be exceeding acceptable guidelines. And so first I'll start with the demographics, just describing the demographics of the general population, and then looking at with respect to each of the different occupations, as there's already like very interesting trends right there. And then I'll step through each of these specific objectives are here while switching between the PowerPoint presentation and then my Shiny app here for a more interactive presentation. So here's just the usual table 1 plot describing the population of our 51,000 participants right here. So across the different cycles, we see that it's a fairly even distributions of participants, fairly even distributions by sex. And then across the different race, we see that these percentages are pretty representative of the US the racial makeup of the US population. For age, we see that almost all participants have age ranging from 16 to 85 as oldest. Poverty income ratio right here is defined. So this is defined as taking what your total household income is and dividing by what that value would be if for you to be considered below the poverty income line. And so 1 and below is implying a ratio of 1 or below means that you're below the poverty income line. And so this can range from 0 to 5. And then we use serum codeine levels to as a biomarker of smoking right here. And so this range from 0.01 to about almost 2,000 right here. And as a note, active smokers are defined as 3 nanograms per milliliters. So that's the general population right here. And so what's more interesting is like, how do these covariates, how do these demographic factors break down by different occupations here? So this is the figure that we have in our manuscript currently, but this is hard to read. And so I want to switch over to my Shine app to demonstrate this right here. And so here we show what's like the age group breakdown for each occupation right here. So we'll start with the top of an unemployed group going to school. And if we hover over this right here saying that 60% of those who are going to school, they are between 16 to 18 years old. That makes sense right there. And then the next age group follow that is about 33% of those are between 18 and 28 years old, and so on and so forth. And so currently right now, this is sorted by those who are 28 years old and younger. And so at the top, you see here, there's quite a few unemployed who has like looking for a job, but mostly comprised of quite a few blue collar workers. And at the bottom right here, this is comprised mostly of white collar workers and those who are disabled and retired, as this makes sense, that as in these groups right here, they tend to be older. And so let's say you want 28, and so this is really graphed by the proportion of those who are younger. Maybe you're in the next age group right here, 28 to 38. And so you can click on here, even if you want to sort the occupational groups accordingly, you can click on it and it will sort based on what you select. So let's go to sex right here. So here we show the breakdown, the percentage of each sex for each occupation here. And so at the top, we see that mining blue colors here, 100% of them are male. And then we can just see like all basically a lot of blue collars up here are comprised mostly of males here, ranging from 92 here to about like 68%. And then on the other end, we see that these occupations right here are comprised mostly of women right here. Those involved taking care of jobs, taking care of their family and an unemployed group, as well as those who work in the healthcare industry, private households, as well as education right here. So we really see a gradient in like percentage in percentage of say male across the different occupations. And then here we'll look at this by race. And so for agriculture, forestry, fishing, white collar, we see here that about 93% of this population right here is comprised mostly of non-Hispanic white collars, a small percentage comprised of non-Hispanic black collars, 2.5 Mexican Americans, and 2% other race right here. And so this right here is sorted by the percentage of those who are non-Hispanic white. And what we see here is that white collar workers, white collar jobs are comprised mostly of non-Hispanic white population. And as we move down here, which are composed mostly of blue collar workers, we see that the population becomes more diverse, but still comprised of a majority of non-Hispanic white population. And then we'll move on to the poverty income ratio right here. And again, poverty income of 1 and below means that you're below the poverty income line. And so we see it. So this is sorted by those below the percentage of those below the poverty income line. And we see that basically most of the unemployed group, which makes sense, are composed, have the highest percentage of those below the poverty income line here, ranging from about 42 to 28%, and then follow after. We see that it's mostly white collars right here. And as we move down the line, we see that white collar workers tend to have a higher proportion of those above the poverty income line. So showing really a gradient of socioeconomic status based off of from blue collar to white collar here. And then finally, for getting up with our demographics, let's check out smoking. And so this right here shows that breakdown by percentage of those who do not smoke. Secondhand smoke 1 to 3, and then above 3 right here is considered active smokers. And so again, at the top, we see here that 62% of mining blue collars here are active smokers. A small percentage is secondhand smoker, and then the remaining are 34.5 are not smoking right here. And then we see at the top, it's those who are actively smoking based off their serum Coney levels are blue collars, some unemployment groups, and mostly blue collars. And then as we move further down the line as the percentage of those who are active smoker lower, we see that most of the job occupations are white collars. So with that ends the demographic portion of this. And so we'll move on to looking at, so here we'll look at actual differences in chemical exposure profiles by occupation. And so that will be, so I'll show this plot right here. Takes it a while to geez up. Okay.
So Vy, can you actually, so I see a few questions, and then I think it's better to clarify that here rather than we are waiting until the end of the presentation. So the question was about this white and blue color. So how you define white color and the blue color, and then you have only just 2 categories. And so can you make some comment on how you define blue and white color in this occupation class?
Yeah, okay, so I see a question like why agriculture fishing shows as white collar. So agricultural fishing is the industry, but within in that industry, there's multiple, there's actually different occupations, there's different jobs. And so Anaheim's right here has different occupational job codes. And so we look at those descriptions right here, and then we categorize based on white or blue collars. And the definition that we use for that is blue collars workers tend to perform more manual labor. And so if we look at their job description and it indicates some sort of like manual labor, they would be categorized as blue collar. And so for each industry, there's a blue and white collar counterpart.
Great. Yeah, you can move on. Yeah.
Okay, thank you. All right, so here we'll look at like how does a given chemical, how does it differ across the different occupation? So here you can select which chemical you want, which chemical family you want. And then from there, you have a slew of other chemical biomarker within that chemical family. So we'll start with lead, as in it's an important neurotoxicant. So it takes a little bit of time to load up a bit. So first, let's just focus on the distribution part right here. And so this is just like the raw biomarker data right here, showing how it differs across the different occupation. So the different colors right here represents, blue right here represents blue collars, white represent white collars, gray represents the unemployment group, yellow right here represents the enhanced population. So here we can also compare with the national average, if you will, and then red right here represents white collars from public administration as our reference group. And so here's the box plots of that. And so what you see at the top right here is that this is currently ordered by the median of lead concentration. So at the top right here, mostly blue collars and unemployed jobs, they have their median levels of lead are higher compared to at the bottom of the plot right here, which is comprised mostly of white collar workers right here. And so you can hover over this and it'll read off what those values right here. And so this right here is like the unadjusted value. And so the next question we want to ask is like, after we adjust for all our covariates, which is age, sex, race, probably income ratio, changes over time, study period, as well as smoking right here, how do these differences change? And so we'll start with top with the construction blue collar right here. And so the interpretation here is that levels of blood levels are on average about 60% higher in this occupation right here compared to white collar workers from public administration right here. And then that difference, this adjusted differences right here, ranges from 51 to about 60%, which is like fairly high right here. And then the asterisk right here represents how significant it is after multiple comparison. And so 3 asterisk right here means that it's like very, very close to zero. There's probably a round off error right here. But even so, this means that even adjusting for all these covariates right here, potential confounders, this difference between construction blue colors and the reference group of public white collar from public administration is still very high. And we see that holds for several of the blue colors right here. And then we see that on this side, with the exception for maybe those looking for work, as well as blue collars from accommodation food services. The average blood level concentrations for these occupations group right here are either lower or fairly similar to our reference group of white collars from public administration. So let's see here. So
can you say, so what this purple triangle indicate?
Oh yes, the purple triangle right here is the geometric mean for each occupation. So let me give some interpretation here on lead. So lead can be found in O1 commercial paint. So I guess the high, if you understanding like why is it higher in construction blue collars could be due to that. Either they're tearing down like older buildings with lead in the paint. Lead can also be found in car parts, battery, glass, and consumer products made of plastic. And so looking at these differences, and then to kind of understanding like where these sources of lead can be, can help understand like why these occupations have higher levels of lead compared to the white collars on this side. So let's see here. We have 20 minutes. Okay. I'll show one more, and then I think we need to kind of move on to other plots right here. So I'll show a VOC. Let's do MP xylene. So this is an interesting one. So Justin pointed this out to me, where if you look at like what industry is on both ends of the distribution, we see here that blue collar workers from professional, scientific, technical service. So that's, I guess, like our industry right here. They have their median levels of MP xylene is the highest at 0.19, and that's almost three times higher than their white collar counterparts from the same industry. So it's just really interesting that even though you work in the same industry, because your tasks are different, you can have very different routes of exposure, and you can also have very like stark differences in a given chemical biomarker. And so Justin made this point of how in histology, xylene right here is widely used as a like clearing agent. And just like with a quick Google search, the reason why I think M-xylene it's higher in, well, particularly professional, scientific, technical services for blue collars is maybe due to how it's used to remove paraffin from microscope slides after staining, and then even after staining, xylene has to be put on to mounting with a cover slip right there. So if there's any recommendation to make there, maybe like when working with, I guess, microscope slides, does one have to use like proper PPE to prevent such exposures? Okay. So with that ends this portion of like defining differences in chemical biomarker levels. So here we just did it one chemical at a time. But then what does this look like with all 129 chemicals that we study? So within like one occupation, can we know like what is the different chemicals, and how does it differ compared to the reference group of white collars from public administration? So with that, I'll do this plot right here. One sec. I'll remove this for now. So this plot right here, we take basically the Bettier coefficients for the occupation, so that percent differences and for a given occupation compared to the reference group of white collars, and we plot it on this plot right here, where so down here, these are the different occupation groups right here, and then the different color bars right here helps determine whether the occupation is blue collar, white collar, unemployed right here, and then we plot the chemicals on the y-axis right here, and then the colors over here helps represents like which chemical family for that chemical right here. And so I'm gonna select mining blue collars, and then kind of a little bit as we go down the line, and basically read off what is a blue collar from mining occupational profile. And so we see here that their DEET acid levels is 215%. And so kind of reference 100% higher equates to 2 times as high as the same levels of DEET acids in the reference group of white collars from public administration. And so this right here, you can interpret it as like over 3 times higher, quite higher here. Same thing with another 2,4-D, another pesticide here, as well as another DEET metabolites. And so I guess a natural question that raises like, why is mining blue collars? Why is there, what does that have to do with like pesticides? And so I think this, I think they could be exposed as pesticides due to just being outside, like when you're digging, I'm guessing after pesticides are being applied can seep into the ground. And then from there, that's a possible route of exposure for mining blue collars. Another interesting fact is that their certain dietary components, just as like these carotenes are like fairly high, about 20, 23 or about 20% higher in mining blue collar workers. Justin brought this up to me, and this is an interesting note because remember that mining blue collars, I think, had one of the highest percentage of those who are active smokers. It's also interesting to note that such these I think beta carotenes have also been implicated in exacerbating like lung cancer if you are already smoking there. So I guess that's an interesting note. And as we keep going down the line, we see that let's see, a lot of VOCs, a lot of other pesticides, a lot of pHs are also higher in this occupation, as well as several heavy metals right here. And then we kind of move further down, kind of like to look at, so those are more like reds right here. So what does the blue represents? The blue represents that these chemicals right here, such as ethylparaben, so chemicals used in personal care products, they tend to be 62% lower in this group, so higher in the reference group of white collars from public administration. And so this kind of indicates to us that those who work in public administration would use more personal care products for either strategic presentation or it's more integral for them to be successful. The presentation is more integral for them to be successful per se. And then that is a little bit corroborated by urinary benzophine levels. So this is a biomarker sun greens juice, also can be found in personal care products. And we kind of see just across the board that it's blue, indicating that it's lower across most of the occupation right here, but systematically higher in the reference group of white collars from administration. So further corroborating maybe like presentation is important for I guess leveling up in their workplace. And so this is quite a lot. And so I guess a natural question that follows up is like, okay, this is a lot of results, like which you're making a lot of comparison here. So which of these is significant? And so I want to uncomment this right here, and this right here will show asterisks to help us like focus on which chemical, which occupation to focus on. And so here I listed like what did these asterisks mean? Having more asterisks means that it's increasingly more significant after multiple comparison right here. And so if I would have to make any recommendations on like which chemicals to further study, which occupation to focus on, maybe I can zoom in on this part right here. And so here we see that like xylene, ethylbenzene, xylene, so volatile organic chemicals, as well as arsenic metabolites right here, and then blood lead. We see that it's higher in several blue collar workers right here. And so I guess, so what chemicals to focus on, I would suggest maybe these VOCs right here, lead right here, and then arsenic metabolites. And then that's just kind of the top part of it. And so we'll resect the axis right here. And then there's kind of a significant group of chemicals right here. So we'll zoom on to this right here. Again, we also see kind of similar stories of these blue collar workers here with other volatile organic compounds, as well as like cadmium right here. And then we see here that BP3 right here is lower in these blue collar workers from these industries right here. And so overall, what I would recommend is that you set right here and then check my notes. So it seems like, so I would say like blue collar workers from construction, other services, professional, scientific, technical services like real estate, manufacturing, and wholesale sort of have some of like the highest levels relative to SEMS of like heavy metals such as cadmium, lead, pHs, VOCs, just as like MP3, xylene, and toluene. And then kind of in summary here, on the other hand, we see that white collars have kind of higher levels of personal care products compared to blue collars right there. And so those would be the chemicals and occupations I would suggest to focus on further either biomonitoring. And so that ends that proportion of the presentation. And so now we move on to, and so 1 and 2 really is looking at relative difference based off of reference groups. But for 3, this is now we're going to look at do these biomarker levels, how do they compare based off of like an absolute, based off of like an acceptable guideline. And so just really basic, basic definitions of a like biomarker equivalent right here. So exposure guidelines, they're really defined on exposure values. So like how much do you and how much do you intake? And so this is the units right here is like milligrams of the chemical per kilogram of the person per day. And so this is really difficult to compare when you have biomarker levels in blood or urine. And so this is why the biomarker equivalents were defined to help convert those exposure values into concentration in their blood, urine, and serum. And so with this, what we're going to do is we're going to compare one's biomarker levels to this biomarker equivalent to calculate percentage of participants in a given occupations who are exceeding this threshold. And so we can first start out a little bit easier. We can look at just like cumulative distribution functions. And so we'll focus on lead as that's the theme, right? As theme right here. And so the biomarker equivalent for lead for non-cancer effects. And so there's biomarker equivalent for cancer right now, but I still have to put that data in. But for non-cancer, such effects could include that are studied are like mutagenesis, developmental toxicity, neurotoxicity, and reproductive toxicity. So for lead, currently right now, it's 10 microgram per deciliter. And so you can hover over this right here. And so this is saying that for construction blue collars, about 2.8% of this population right here has blood levels exceeding this threshold right here at 10. And then as we go to the top, we see that these occupations, they don't have, there's no one exceeding that threshold right here. But there's been, this threshold, this biomarker equivalent is kind of in question right now, as in maybe it should be lower, or really there's like really no safe levels lead. And so what you could do is, so one of the papers that I found is that the suggestion is lower to 1 microgram per deciliter. So if it should be lower, then that would mean that construction blue collar workers, 90% of construction blue collar workers have lead that exceeding this threshold, this say proposed threshold is right here. And then on the other end, it's going to school, so it's fortunate of that. Usually the younger population, they're not a high proportion of their levels are not a high proportion of them have blood levels exceeding this say proposed new threshold right here. And so currently right now, blue collar workers from accommodation food service is highlighted as there's like, I think like 47 occupations here. So sometimes it's like hard to find like, what is your favorite occupation right here? So I can just click on this right here, and then the line will be colored or sorry, emphasized if you want to make, say, a comparison between accommodation food service blue collar versus construction blue collar workers. So now the next question. So you can look through all this, and that is done on a chemical time, but what about looking at this like all together? And so that would be our heat map right here. And so this right here, so this shows the percentage of those who are exceeding that biomarker equivalent for 29 different chemicals right here that have some sort of data on that biomarker equivalent for non-cancer effects. So I'll select, let's just start with like one chemical family and kind of read off what this means here. So for some of arsenic metabolites right here, this right here says that there's the biomarker equivalent at 5.8 micrograms per liter, and 40% of construction blue collars have levels of arsenic metabolites exceeding this biomarker equivalent. Here it is for pesticides right here, 17%. And so for VOCs, we have 23%, 19% for MP-xylene right here, and so on and so forth. For cadmium right here, let's see here, that's about 1.8%. And then for these chemicals right here where it's white, this right here, 0% of the population of blue collars from construction have their levels are not exceeding these thresholds. And then here we have lead again with a 2.82% exceeding that biomarker equivalent. And so here we use a clustering analysis right here to group occupations together based off kind of like their similarities in profiles of having biomarker levels exceeding the thresholds right here. And it's kind of interesting to note that on this side, it's comprised mostly of blue collars and unemployment group. And on this side, it's comprised mostly of white collars right here. And so on this side, I guess that would mean that blue collar workers and those who are unemployed have a very similar exposure profiles of biomarkers exceeding biomarker equivalent. And we see here that they tend to have higher levels in such some of the more toxic chemicals, such as these heavy metals, glycidamide and acrylamide, as well as VOCs right here. And so if I would have to make any recommendations based on this plot right here, what I would suggest is that I would focus on several of the blue collars and unemployment groups on this side, consisting of like from private household, healthcare, so on and so forth, and then start to understand why are these biomarker levels exceeding that, and for so many people trying to understand like what are the sources of exposure to lead to that excessiveness. Let's see here. And so that ends finishes of all the different specific objectives right here. And so really in summary, we evaluated differences in chemical exposure by occupation. And we found that this was essential to really identify several occupations exposed to high exposure, but also high risk to adverse health outcomes in terms of non-cancer effects when we incorporate data on biomarker equivalents. We list blue collar workers from these industrial jobs right here, as well as several unemployed groups have really higher levels of some of the most nasty chemicals as listed here compared to their white counterparts. And then for 2, when we say we could correlate just a few of those when we look at those percentage with biomarker levels exceeding any acceptable exposure guidelines right here. So overall, we hope that such analysis, that we have a framework to help direct like which occupation, which chemical to further focus on, either for further biomonitoring, health risk assessment, or targeted intervention to mitigate such negative effects from toxicant exposure. And so with that, I'd like to thank Meredith and Sung-Kun for arranging this, as well as Robin for letting people into the talk. And then I'd like to thank all 3 of my bosses, as well, all 3 of my labs for giving me the financial means as well as the space to do all this work. And thank you so much for listening.
Great. So this is very interesting presentation, and especially this visualization is fantastic. So I appreciate this presentation. And so we have several questions in the chat box, and I don't know. So you can see that, and you can just read that. And then one question from Elizabeth is, how is the chemical exposure characterized for workers with 2 or more occupations, either blue or white color? So when they have 2 or more occupation, how did you handle this?
So we specifically use so in NHANES, so kind of short answer is that for this analysis you can only have 1 occupation, and so we use what is their occupation, what is their job title on their current job right here. So you can only have 1 occupation right here. But there's also another variable you can use where it's what's your occupation based off of your longest job. So unless you use 2 of these variables, you are restricted to like just 1 occupation here.
Maybe the related question. So then, did you use? My understanding in NHANES is there is like a current occupation and the longest occupation. So did you use just current occupation in your analysis?
Yes, okay. I use current occupation. I think for longest, it's only available for 3 cycles. So that may just be like 24,000 participants, maybe. While for the current, I use the current occupation because that ranges from 1999 to 2014. So that would give us the largest sample size. And then the other question, so Ted has several questions. So maybe Ted, so do you want to unmute and then you ask directly?
I can do that, thank you. Thanks for the presentation, and I don't envy you your task of dealing with this massive amount of data. But one of the questions that comes out of these hierarchical clustering maps is what's real and what's not. And so one way to interpret these is to go way up to the top where you're seeing where's the binary break, where's the 3-way breaks or 4-way breaks. These are sort of the high level gross ways of dividing the cluster map both vertically and horizontally. And I'm just curious if, I know you made the comment that I guess to the right of the one you're showing was more blue collar and the left is white collar. Is that one of your conclusions then, or can you conclude something from that?
I would say, one of my conclusions that it seems to like separate. It seems that so based on this thought, one thing that I would still want to correlate more on this is that it seems like one's chemical exposure profile, if you look at it by occupation, seem like collar type seems to be more predictive of what your chemical biomarker level is.
The exceedance.
Versus,
okay. Right. But yeah, okay. But so am I correct then that if you go to the highest level of the hierarchical cluster, the vertical one, and you just look at that first break, there. And then all the subclusters, you see that you've broken it down the middle there. The gap is down the middle. So
yeah,
is that
exactly.
Is that blue versus white?
I would maybe qualify a bit as saying like on mostly blue versus mostly white.
Yeah. Okay. And you can. I'm sorry to cut in. Sorry. And then looking on the horizontal scale, then from the right side there, you also have a big break or a couple of them. So there's the one that's the lowest category there is all by itself at the lowest level. Sum of arsenic metabolites. It looks like that's very different from everything else, which is interesting. And then the next break is, well, I don't know how to classify that, but that seems to be one of your key challenges is to try to make sense of those big ones. Yeah.
Right, exactly. And then, yeah, I guess, Ted, you're getting at a point where with clustering analysis, the results can change like very dramatically based off of, say if I put like maybe another chemical in here, the results could, like the dendrogram, the clustering analysis could change dramatically. So,
oh yeah, it also depends on what your metric is, your connecting metric, whether you use a centroid or closest neighbors, or there's different ways, and that can change things too. So if you did want to get down into this, you probably want to see which trends are resilient to those variables.
Yes. So we didn't do it with this plot, but we did it with this. So this plot right here was showing like how percentage of those exceeding biomarker equivalent. This plot right here shows the percent difference right here, and then we did try a different I think linkage measures, and I still need to confirm this, but it seems like there's this general pattern of being separated. On one side, it's mostly blue color. On the other side, it's mostly white colors. But I can definitely run such analysis for this plot right here, just to see if like these patterns are consistent across different metrics, across different linkage measures, and just like different criteria of clustering analysis.
Yeah.
Okay, so we are almost time. So we have one more question. So you can see also that from the chat box. So have you tried to link this risk information to rates of healthcare access and or income by occupation to see if those occupations most at risk also have low access to healthcare, low income, potentially posing an occupational justice issue? So can you make some comments?
Okay. So someone help me here, but I think there's Medicaid data there, but that's restricted right here. There may be other variables in NHANES where it's some sort of surrogate for healthcare access. So I could put that in. I could definitely look at how healthcare access could differ by occupations right there, but I would need to go grab that data.
Yeah, great. I think, yeah, so NHANES data can be linked to Medicare, and probably so that could be the potential source. But access to Medicare is not easy, so that's why. But so this could be a very interesting future direction you can try.
For sure, but but we do have income in here as shown with, and I feel like income is very heavily tied to access to healthcare. So if to answer this question, or to muddling through to answer this question, this right here may help indicate that, as we see that predominantly blue collar workers have food block works, and of course unemployed groups have lower socioeconomic status, and that could indicate that they may have less access to healthcare.
Great, thank you. So thank you everyone to having this seminar series, and then so we will see you in 2 weeks when Dr. Sean Harris at EHS will be presenting. So we will announce the next the seminar soon. So please stay tuned, and then see you then, and then have a great day. Thank you.
Thank you so much, everyone.